Hello YouTube and welcome back. I am Benjamin Williams and today we're going to be doing another lab within Boson NetSim. Today's lab is going to be on configuring an NTP server. So let's go ahead and read what we're going to be doing in this lab by reading the objective. It says network time protocol is essential to the functioning of many network services, particularly those that provide event logging, authentication, or encryption. Because these services can be manipulated or even disrupted by incorrect times, it is vital that mechanisms are put in place to validate NTP packets and to restrict NTP synchronization to authenticated devices. In this lab, you will learn how to configure client devices to authenticate NTP packets from the NTP master NTP server and how to use access control lists and NTP access groups to restrict NTP synchronization from the NTP server and the NTP clients. It says, note, you should allow time for NTP polling interval expirations in several steps in this lab. To facilitate the speed at which the lab can be completed, NTP timers are faster in NetSim than what you would experience on live equipment. Okay, so if we take a look at our lab topology, we can see that we have router C. It has a switch. It has two switches connected off of two interfaces, switch A and switch B. And then we have router A off of switch A, and we have router B off of switch B. Okay, so we can take a look at the commands that we're going to be using in this lab. We have access list number, deny or permit, source address, source wildcard. This creates an ACL that denies or permits IP traffic from the specified address or address range. We have clock set. You set the hours, the minutes, the seconds. Then you would set the day, the month, and then the year. This sets the system software clock. We have configure terminal, which enters global configuration mode from privileged exec mode. We have enable, which enters privileged exec mode. We have end, which ends in exits configuration mode. We have exit, which exits one level in the menu structure. We have no NTP. This removes an entire NTP configuration from a Cisco device, including any NTP authentication or access groups configured on the device. Okay. We have NTP access group. We can specify peer, serve only, query only, and then we'll specify the access list number. This configures an access group to control NTP access and applies a standard IP access list. We have NTP authenticate. This enables NTP authentication. We have NTP authentication key, number, MD5 value. This defines an authentication key for NTP. We have NTP master stratum. This configures the Cisco iOS software as an NTP master clock to which peers synchronize themselves. Okay. We have NTP server IP address key ID. This allows the Cisco iOS software clock to be synchronized by an NTP time server. We have NTP trusted key number. This authenticates the identity of a system to which NTP will synchronize. We have ping IP address. This sends an ICMP echo request to the specified address. We have show access list number, or we can specify the access list name. This displays the contents of current ACLs. We have show clock details. This displays the time and date of a system software clock. We have show NTP associations detail. This displays the status of NTP associations. We have show NTP status. This shows the status of NTP. And then we have show running config, which displays the active configuration file. Okay. So Boson also provides us with an IP address table, which specifies the device names, all of the interfaces on each device, the IP addresses on each device, and then the subnet mask of those interfaces. So we would definitely refer back to this IP address table as needed throughout the lab. But without further ado, let's go ahead and get into our lab task. We're going to keep our lab topology in the top left. We're going to be doing our lab readings in the top right. And we're going to be doing all of our device configuration down here at the bottom. Okay, so let's go ahead and get into task number 1. Task number 1 says configure NTP. It says in this task, you will configure NTP on router C, router A, and router B. Router C should provide NTP time synchronization services to both router A and router B. So it says on router C, issue the command to set the clock to 8:01 a.m. Coordinated Universal Time UTC on June 25th of 2024. So let's go ahead and go over to router C, and this is going to be our NTP server, basically. That's what the lab just said. So let's do an enable, and let's do a set clock, because we want to set the software clock, or is it clock set? Let's do a clock set. Yep. All right, so let's specify we want to do 08 colon, then we'll specify the minutes, which will be 01, then we'll specify the seconds of 0 seconds, and then we want to do the day of the month, so we'll be doing 25. The month of the year, let's do June, and the year we want to specify 2024. All right, that looks good. So let's set the clock like that. And then number 2, it says, on router C, issue the command to verify the current time. For what source is the time and date set? So let's do a show clock detail. Hit enter. And we can see that we have a time of 8:01 that we just specified for June 25th, 2024. And the time source is user configuration. And that is because we just set this manually. So number 3, it says on router C, issue the command to enable NTP by configuring router C as an NTP server. Use a stratum of 10. Okay, so let's configure router C as the NTP master server. So let's do a configure terminal. Let's do a NTP master and specify the stratum of 10 and hit enter there. Number 4 in Boson says, what is the importance of stratum values in NTP? Well, stratum value specifies the authority of this NTP server. So the lower the authority, the higher believability, I would say, of the time source. So let's see what Boson is going to say. It says the authority of a particular time server is indicated by a stratum. An NTP server receives its time information from a time source with a higher level of authority than itself. The NTP master stratum command enables you to configure an internal device to act as a authoritative time source. Stratum 1 devices, which are typically public servers, are considered the most authoritative sources of clock information in the NTP hierarchy. Stratum 1 NTP servers distribute their time information to devices in the higher strata. For example, Stratum 2 devices function as NTP clients to Stratum 1 devices and as NTP servers to devices in a higher strata. So yes, that makes 100% sense. So number 5 says, on router C, issue the command to verify the current time. From what source is the time and date set now? So let's just hit the up arrow. Oh, no, let's hit N first. Let's do an N and hit the up arrow because we want to do a show clock detail again. And now we can still see that we are still at 8 o'clock. We're at 8:03 now. We still have June 25th, 2024. But now our time source says it is NTP. And that is because we configured the NTP master command on router C. Okay. So number 6 says, on both router A and router B, issue the commands to display the current time. Is the time on either router A or router B synchronized with any time source. Well, let's figure that out. Let's go to router A. Let's do an enable, and let's do a show clock detail. And we can see that this clock is actually set to Monday, March 1st, 1993. And we can see that it has no time source. So we can definitely see that router A is not synchronized to any type of NTP server. Let's check on router B. Let's do an enable, and let's do a show clock detail. And same thing here. These clocks are set way back in time. This one is Monday, March 1st, 1993 as well. And it also has no time source. Okay. So number 7, it says on router A, issue the command to configure NTP to synchronize the time from router C. To synchronize the time with router C through router C's fast Ethernet 00 interface. So let's go to router A. Let's do a configure terminal, and let's do a NTP, and we want to do a server, NTP server, and we want to specify the address of 10.10.10.1. Okay, let's hit enter there. Number 8 says on router B, issue the command to configure NTP to synchronize the time with router C through router C's fast Ethernet 01 interface. So let's go to router B. Let's do a configure terminal. Let's do an NTP server of 10.10.11.1. All right, let's hit enter there. Number 9 says on both router A and router B, issue the commands to display the current time. Is the time on each device synchronized with the NTP source? Well, let's give it some time, because as we know, NTP does its expirations at different timing intervals. So we have to give NTP some time to get its clock synchronized. So it may have been enough time on router A. Let's do an N, and let's do a show clock detail. And yes, this router A is now updated. We can see it is now with June 25th, 2024. And the time source is NTP. Let's check on router B. Let's do an N. Let's do a show clock detail. And this clock is yet to update. Let's give it a few more seconds. And it should update, because we configured the NTP server up here. Like I said, we have to give NTP some time to synchronize this clock. And yes, we have now updated the time. It is now Tuesday, June 25th of 2024, and the time source is now NTP. So number 10 says on router A, issue the command to display the status of NTP. What stratum is being reported and why? So let's go to router A. Let's do a show NTP status. It wants to see the status. So we can see, and the question was, what stratum is being reported? Well, the stratum that is being reported, and my mouse just died, so give me 1 second to plug it up, and I will be right back. All right, so we're back. Where we left off at, we were trying to figure out what the stratum was for router A. And router A stratum, as we can see, has a value of 11. And that is because we configured the server to have a stratum of 10. So the client is going to have a stratum 1 higher than the server. In this case, it has a stratum of 11. Okay, so number 11 on here says on router A, issue the command to display the NTP associations. From where is router A's time being synchronized? What is the stratum of the NTP source? So let's do a show NTP associations. Okay, and we can see the first question was, where is router A's time being synchronized? We can see that its time is being synchronized from 10.10.10.1, which is router C. It says, and what is the stratum of the NTP source? The stratum we can see is 10. Okay, we can also see the reference clock that is referencing as well, which is the hardware clock on router C. Okay, so task number 2, it says configure NTP source security. it says Cisco devices can use NTP authentication to verify the source of NTP packets. In this task, you will configure NTP authentication on router C, router A, and router B so that packets from router C are verified by router A and router B before router A and router B use those packets to synchronize their clocks. Okay? So number 1 says on router C, issue the command to display NTP associations. What administrative source is being used to synchronize the time? So let's go to router C and let's do a show NTP associations. And the first question was, what authoritative source is being used to synchronize the clock? Well, we can see that it is using its local clock, which is 127.127.1.1. And we can also see the reference clock says .local. Okay? So it's using its internal software clock because we configured the clock up here. Okay? And we configured it to also be the master with this command. All right, so number 2 says, on router A, issue the command to display the NTP status. Is router A receiving its time from router C? Well, it should be because we configured that earlier in this lab. But let's do a show NTP status to see. And the question was, is router A receiving its time from router C? And if we take a look, we can see the reference clock is 10.10.10.1. And if we go to router C and we do a show IP interface brief, we can see that if we go back to router A, 10.10.10.1, if we go to router C, 10.10.10.1 is the fast Ethernet 00 on router C. So yes, it is synchronizing, it is receiving its time from router C. So number 3 says on router C, issue the command to enable NTP authentication. So on router C, let's do a configure terminal. Let's do a NTP authenticate. NTP authenticate. Number 4 says on router C, issue the command to configure NTP authentication key that uses an ID of 1 and a password of Boson. How does NTP use authentication keys? Well, let's figure that out. Let's do, I think it's MD5, but let's do NTP. Let's get some context sensitive help. Let's do an authentication key. Authentication key. We want to do a ID of 1. And yes, it is MD5, as we can see, MD5 authentication. And we want to specify the authentication key of Boson. All right, and let's hit enter there. Number 5 says, on router A, issue the command to display NTP associations. Is router A still synchronized with router C? Why or why not? Well, let's figure that out. Let's go to router A. All we did was enable authentication on router C. So let's see if router A is still synchronizing its time with router C. Let's do a show NTP association. And it looks like router A is still synchronizing with router C. Yep, that's still the same IP address. It says that it is the master with the asterisk and it is synced. Okay, so everything looks good. Number 6 says on router A, issue the command to configure NTP to use authentication. Okay, so on router A, let's do a configure terminal. Let's do an NTP authentication, authenticate, excuse me. All right, now number 7, it says on router A, issue the command to configure an NTP authentication key that uses an ID of 1 and a password of Boson. So that's going to be a similar configuration that we just did on router C. So let's do an NTP authentication key of 1 and a MD5 of Boson. Hit enter there. Now, on number 8, it says on router A, issue the command to configure NTP authentication to trust packets from only NTP devices that authenticate by using authentication key 1. What will router A do with NTP packets that claim to be from router C but do not use the trusted key? Well, if we configure a trusted key on router A, if it receives a NTP packet that claims to be from router C but does not use the trusted key, it will drop those packets, okay? So let's configure a trusted key on router A. Let's do an NTP trusted key of 1. Okay? Now number 9 says on router A, issue the command to configure NTP to synchronize over router C's fast Ethernet 00 interface. You should modify the configuration so that it uses NTP authentication key of 1. All right, so let's do a NTP server of 10.10.10.1, and let's do a key of 1. Okay. Now number 10, it says on router A, issue the command to display the NTP status. Is router A still synchronizing its time from router C? And it should be. Let's do a N. Let's do a show NTP status. And yes, it is still synchronizing its clock from router C. Okay. So number 11 says on router B, issue the commands to configure NTP to use authentication. So on router B, let's do a configure terminal. Let's do a NTP authenticate. All right. Now number 12 says on router B, issue the command to configure NTP authentication key that uses an ID of 1 and a password of Boson with a $sign. Ensure the password is not identical to the password configured for authentication key 1 on router C and router A. So I guess we're going to misconfigure this one on purpose to see what happens. Okay, so let's do an NTP authentication key of 1 and a MD5 password of Boson. Hit enter there. Oops, I did that wrong. It needs to be a $sign. Boson. Okay, yep, that looks good. So now it says, and let me do a show run. Let's do a do show run to make sure that that was configured with a $sign. Yes, it was. Okay. So now it says on number 13, it says on router B, issue the command to configure NTP to trust only NTP devices that authenticate by using authentication key number 1. Let's do that. Let's do an NTP trusted key of 1. Hit enter there. Now it says on router B, issue the command to reconfigure NTP to synchronize over router C's fast Ethernet 01 interface. You should modify the configuration so that it uses NTP authentication key number 1. So let's do a NTP. And we want to do a server of 10.10.11.1, and we want to do a key of 1. Number 15 says on router B, issue the command to display NTP associations. Is router B still synchronized with router C? Why or why not? Well, we misconfigured the authentication key, so it probably will still synchronize, but let's see what it's going to do. I'm not sure at this point. Let's do a show NTP associations, and I may need to give it some time as well. Okay. So yeah, we're unsynced. And you can see we have the pound symbol. It says master unsynced. So that doesn't look good. That's that pound symbol right there. We have a stratum of 16, which is also not good. Yeah, so it's not synchronizing, and that is because we configured the wrong. We're still synchronizing, but it's not believable because we configured the wrong authentication key. Okay. So number 16. It says on router B, issue the command to remove NTP configuration. Okay, so let's do a configure terminal. Let's do a no NTP. A no NTP. All right. And that should have removed everything. Let's confirm that. Let's do a do show run. And yes, all of our NTP information is now going in our running config. So now let's do a, it says on router B, issue the command to configure NTP authentication, including an authentication key that uses an ID of 1 and a password of Boson. Ensure that NTP attempts to synchronize over router C's Fast Ethernet 01 interface and uses an authentication key of 1. Okay, so first let's do a NTP authenticate. Okay, let's do an NTP authentication key of 1 with MD5 of Boson. Let's do an NTP server of 10.10.11.1.1, and we want to do a key of 1. We want to do a NTP trusted key as well of 1. All right, that should be it. Let's go to task number 3. It says configure NTP client security. It says, although NTP authentication verifies the source of NTP packets, it does not prevent NTP clients from synchronizing with other unauthenticated sources. In this task, you will configure ACLs in NTP access groups to ensure that router C can synchronize time to only router B and router A. And you will also configure ACLs and NTP access groups on router A and router B to ensure those devices can receive their time only from router C. Okay? So, number 1 says on router B, issue the command to display detailed information about NTP associations. Is NTP on router B synchronizing with router C? Well, before it wasn't, and that's because we configured it with the wrong MD5 password. Let's try now. Let's do an end. Let me take caps lock off. And let's do a show NTP association detail. Okay. And we can see that now our stratum is back down to 10, which looks good. We're valid. We're sane. These are all good keywords to see. We're configured with the IP address of 10.10.11.1. That is our master. So everything looks good here. So number 2, it says on router A, issue the command to display NTP association. Is the NTP on router A synchronizing with router C? Let's see. Let's go to router A. Let's do a show NTP associations. And yes, it is synchronizing with router C as well. So number 3, it says on router C, issue the command to create an ACL with an ID of 10 and configure it to match permitted traffic with router A's Fast Ethernet 00 interface. So let's go to router C, and we want to create an ACL. So let's do an access list of 10, and we want to permit, and we want to do an IP address of 10.10.10.254 and a wildcard of 0.0.0.0. And let's hit enter there. Number 4 says, on router C, issue the command to configure NTP to synchronize its time only to router A and to deny NTP control queries by using an ACL of 10. NTP should not be able to synchronize router C's time from router A. Okay, so from router C, we want to do a NTP. Let's get some context sensitive help. Let's do a group access. Group access. I don't know why it's not allowing me to. Access group. That's why I'm putting group access instead of access group. NTP access group, and we want to do a let's do a serve only. Serve dash only. Okay, and we want to do only access list for the access list of 10. And I say enter there. All right. Now it says on router A, issue the command to display NTP associations. Is router A synchronizing its time with router C? And it should, because we just permitted the IP address of router A to synchronize its time to router C. So let's confirm. Let's go to router A and let's do a show NTP associations. And yes, we are still synchronized up with router C. Number 6 says, on router B, issue the command to display detailed information about NTP associations. Is router B synchronizing its time from router C? Well, we didn't specify router B, so let's see what happens. Let's do a show NTP associations detail. And it looks like we're still synchronized. I'm not sure if we need to give it a little bit more time. But it says that we're sane, we're valid, have a stratum of 10. We're still configured. So everything looks good. Yep, everything still looks good. Let's see what Boson is going to say. Yeah, so it says, based on the output, you can determine that router B is still configured, but the server is not synchronizing. So maybe we just need to give it a little bit more time. It's still showing everything is good on my Boson. Maybe I'm not being patient enough. Give it a couple of more seconds. See if it's going to change. But if not, we're going to keep the lab rolling. Oh, there it is. There it is. So it has changed to insane now. It is unsynced, and we can see that the stratum has changed as well. And sometimes you have to give NTP some time because it does its polling over different timing intervals. So now it says on number 7, it says on router C, issue the command to modify the ACL 10 to permit traffic from router B's fast Ethernet 00 interface. So now we're going to allow router B inside of the ACL on router C, so it should be able to synchronize its clock back up. Okay, so let's do an access list of 10, and we want to permit 10.10.11.254. We want to do a wildcard of 0.0.0.0, and let's hit enter there. And now it says on router B, issue the command to display NTP associations. Is router B synchronizing its time with router C? Well, let's see. Let's go back to router B and let's do a show NTP associations now. Oops. Didn't mean to do that. But we're still not synchronized. So let's give it some time. We just modified that ACL, and like we said, we have to give NTP some time. So let's see if it's going to go back to being synchronized. As we can see, we're still unsynced, and we can tell that by this pound symbol. If we were synced, we would have an asterisk. Okay? Yeah, so we're still unsynced. Let's see what Boson. Do we need to wait? Yeah, so we need to wait because this is showing that it is synchronized. Yep. And as we can see, we now have the asterisk. So we are synced up now. Okay. So it says, number 9 says, on router A, issue the command to configure an ACL with an ID of 10 in the access group that prevents router A from synchronizing its time with any device other than router C. So now we're going to configure an ACL on router A so that it can only synchronize its clock to router C. Okay, we just did that for router C. We basically allow router C to only send NTP packets to router A and router B, Now we're only going to accept packets from router C, from router A, and router B. Okay, so let's do a access, or let's do a configure terminal first. That'll be good. All right, and now let's do an access list of 10. We want to do a permit of 10.10.10.1, 10.10.10.1. There we go. We want to do a wildcard of O.O.O.O. Say enter there. And let's do a NTP access group. And we want to only do a peer. You just want to peer to router C with an access list of 10. All right. Now on number 10, it says on router B, issue the command to configure an ACL with an ID of 10 and an access group that prevents router B from synchronizing its time with any device other than router C. So let's go to router B. Let's do a configure terminal. Let's do a access list of 10. Let's do a permit of 10.10.11.1 O.O.O.O. And let's do a NTP access group peer of 10. Number 11 says on both router A and router B, issue the command to display NTP associations. On router A and router B synchronizing their time from router C. Let's see. Let's do a end. Let's do a show NTP associations. And yes, it is synchronizing its time from router C. Let's do the same thing over here on router B. Let's do a end and let's do a show NTP associations. And yes, it is also synchronizing its time with router C. So number 12 says on router C, router A and router B issue the command to display detailed clock information. Are the time consistent across the devices? Well, let's check it out. Let's do a show clock detail. Over here, let's do a show clock detail over here. Let's do a show. Let's do an end and let's do a show clock. If I can spell clock detail. All right. And we can see that we have June 25th, 2024 at 8:33. This one is June 25th, 2024 at 8:33. And this one is also June 25th, 2024 at 8:33. So these clocks are synced up. So this looks to be the end of this lab. So let's hit grade and hopefully we did everything correctly. And we did. So I appreciate you guys for watching this one and I'll see you in the next one.